This is section 3.4a, which is like part B, basically, of section 3.4. This is an excursion section. Some of the excursion sections we skip throughout the book. Some of them we do. This is a good one that we do. So, you have a couple different types of symmetry here. First one they talk about is y-axis symmetry. Basically, it's like, is it symmetric about the y-axis, okay? Number 2, x-axis symmetry. And then the third one is origin symmetry, which doesn't have a heading on it, but it's there, right there. Origin symmetry, those are the 3 types of symmetry that we will talk about, okay? So, if something is symmetric about the y-axis, like this circle is, or ellipse, I guess is what it is, he is symmetric about the y-axis. Oh shoot, I'm going to die here pretty soon. No, my computer's going to die. Cade.
It's okay, we're all going to die someday.
Go run to Mr. Hubble's office and grab his power cord real fast. Okay? We'll continue on without you. You're all right, Cade. Okay, so.
Caitlin, take my notes.
Take good notes. All right. So, this ellipse is symmetric with respect to the y-axis. What is another, like, really nice, super good function that's symmetric with respect to the y-axis? Can you think of one? That if you fold it across itself, it is symmetric with respect to the y-axis. A parabola. Y equals x squared. If you fold him across the x-axis, just y equals x squared, he is symmetric with respect to the y-axis. Now, not every parabola is symmetric with respect to the y-axis. For example, this guy is not. No y-axis symmetry. Right? That's a parabola, but it's not symmetric with respect to the y-axis because if you fold it over the y-axis, if you take and split this line right here and fold him over there, he doesn't fold on top of himself. Does that make sense? Okay? His axis of symmetry has to be the y-axis, all right? So, here is how you determine whether something is symmetric with respect to the y-axis or not. And it is this guy. Circle xy and circle negative xy, okay? Those are the important guys, all right? If you are looking at, like, let's say the point 2, 3, that's the point that I always use, 2, 3. If I reflect him across the y-axis over here, what does his coordinate become? If I reflect him across that y-axis, what does he become? Negative 2, 3. That goes with the rule. xy becomes negative x, y. Do you see that? All right. Now, if I'm given a function like this guy, here's how you determine whether he is symmetric with respect to the y-axis or not, because we don't want to graph it. That's ugly, right? If we graph it, we can see whether he's symmetric or not, but we don't want to do that. We want to be able to do this the easy way. This is a quartic function, x to the 4th power. So what we do is we take the x and the y, just like the rule says, and we replace it with negative x, y. Okay? So basically the y coordinate is not going to change. I'm going to leave it as just y. Okay? And every x in there, I'm going to replace with negative x, okay? So that's going to be negative x to the 4th power minus 5 times negative x squared plus 3. When you plug them in, always put it in parentheses. Always in parentheses, okay? Otherwise, you're going to be in big trouble, okay? Thank you.
I was in there. April hadn't to get me in there.
Oh, thank you. All right. Okay, now, when we simplify that, negative x to the 4th power, that's basically like saying negative x times negative x times negative x times negative x. When I do that